Hi everybody and welcome. Today we're going to be talking about substitution and elimination as a way to solve systems of equations. So your goal after watching this video will be able to solve a system of equations algebraically using either substitution or elimination. So in our last class we were talking about different ways to conceptualize what a system of equations is and that they intersect when two graphs cross. So what we're going to actually be doing today is solve for the exact points where those graphs cross. And if you finished yesterday's work, what you probably saw was that it got a little bit frustrating at the end because you weren't able to tell exactly where those graphs were crossing. So this method eliminates any guesswork with graphs crossing, and it tells you exactly the point all the way down to that minuscule decimal of exactly where they come together. So first word for today is substitution. And this is defined as when we replace one term with another term of the same value. So if you've ever seen those old-fashioned scales, basically it's almost like you have a long piece of wood, like a 2x4 resting on a point. And if you had an equal weight on this side and an equal weight on this side, it didn't matter if it was different objects, they would balance as long as their weight was exactly the same. So what we're trying to basically conceptualize here is that, let's say we have 8 pounds on this side, and then we have 2 times 4 pounds of weight on the other side. Well, 2 4-pound weights is the same thing as 1 8-pound weight. They both equal out 8 total pounds. So what we're thinking of now is that this equal sign here is just a balance. As long as the left and the right have the same amount of weight, everything's good. We can interchange them. So interchanging is the key idea for today. So we first want to isolate a variable. Isolate means get it alone. After we have a variable alone, we can substitute or replace that variable with something that's the same weight. So for a variable in a different equation in this case. And last, we can solve by combining any like terms that we have. So in our examples here, what we're going to see is we have something like y, and we have something like 2. Well, I'll actually keep them the same color because y and 2 have an equal sign in between them. And what that means is the y is equal to 2. 2 is equal to y. They are the same thing. So anywhere that we see a y, what that allows us to do is in its place, instead of writing down y, we can write down the thing that's the same as it, which is a 2. So everything else is exactly the same. So the 4x and minus 2, 4x and minus 2, unchanged, equals 12, unchanged. The only thing that we've done here is we've just replaced our y with an equal value. So y is equal to 2, we're allowed to do that, so we just interchanged y with 2. So from here, all that we're going to do is just draw our equal sign line down and continue to solve. So we keep 4x, minus 2 times 2 is minus 4, and then 12 remains there. We can add 4 to both sides. So we're left with 4x equals 16, divide both sides by 4, and we'll get an answer of x equals 4. Now the key to a system of equations is actually that we have 2 answers for every single system. So in this case, we have an x and a y as our answer. So we know we just solved that x equals 4, and now we have to see, okay, what does y equal? We have to get just a number for y. So you have 2 options. You can use either equation, so you can use the first equation or the second equation, and your goal is to take what you already know, which is the value of x, to plug it back in and to find a value for y. In this case, the equation on the left already does it for us. We have y equals 2, so we don't need to do anything more. But we could also, if we wanted to, go back to our original equation, so our second equation there, and we could take our x value. So now we can see that x is equal to 4. So what we're going to do is we're going to put, instead of an x next to the 4, we're going to put in the actual number 4. So 16 minus 2y equals 12. Subtract 16 from both sides. Minus 2y equals minus 4. And what we're going to see, divide both sides by -2, is that y equals +2. So it doesn't matter which equation you plug into, it will give you the same answer every single time, guaranteed. So what I'm going to ask you to do now is follow those same steps. Visualize this as y and 7 being the same thing. And everywhere that you see a y, put a 7 in its place. So I'm going to have you go ahead and solve this one now. All right, so steps for solving here. Everywhere that we see that red where the y went, we're going to replace it with a 7. So that used to be 2y there, but we get to replace this with a 7. So 2 times 7 gets us 14. And from there, draw our algebra line straight down. Subtract 14 from both sides. Minus 4x is 6. Divide both sides by -4. And x equals -1.5. In this case, there's no rounding, so -1.5 is okay. You are allowed to have a decimal if it doesn't round, so no big deal there. Second, we have to remember, though, that we're not quite done. We need an answer for y. So we could take that -1.5 and plug it back into our initial equation, but instead we can see that our second equation actually already gives us a number value for y, and that number value for y is just 7. So final answer is -1.5 and 7. All right, so that is one type of solving systems. Our second type of solving systems that we're going to see is elimination. So in this process, what we are doing is we are going to transform a system in a way that reduces the number of variables. So what our goal is if we have a system, so let's say we have two equations, and let's say the variables are x and y, after we've done elimination, that's going to lead us to reducing it. So what we're going to see is we are now going to go from two variables to just one variable. So if you started off with both x and y, and after doing elimination you still have both x and y, you haven't actually done it successfully. In order to do this, what you need to do is eliminate one of them. So one of them must be completely gone. So all of x is gone or all of y is gone. And that's what elimination means. So first what we want to do is we want to line up each equation matching our like terms. Second, we want to combine the equations to eliminate a variable. It doesn't matter which variable, you get to choose here. Sometimes there's a better strategic choice, but you get to choose. And then finally solve for the remaining variable. So the first thing that we want to do is do some color coding. So everywhere that we see an x, we'll put red, y's are green, equal signs are yellow, and let's say blue for numbers. And we have to make sure of, absolutely certain, is that straight up and straight down, everything matches. So red on top of red, blue on top of blue, everything has to match. If it doesn't, we have to rearrange it so that it does. So in our first case here, everything does match, x on top of x, y on top of y, so we're happy. And what we do now is we introduce our algebra lines. So straight up and straight down through the equal signs. Make sure you do this in between the variables, but don't cut off the signs. So we're going to keep the pluses there. And all that we're doing is we're lining everything up. So we're separating it into x's, separating it into y's, separating it into numbers. So in red here, we have our 4x minus 4x. So if you have 4 minus 4, we just end up with nothing, no x's. In green, we have 8y and 2y. So add 8 and 2 together, and we end up with 10. And then in blue, we end up with positive 20 and negative 30, which gets us to negative 10. So from here, what we can see is we've accomplished our mission. 0x is gone. So basically what that means is we've just eliminated x. It no longer is with us. So we have 10y equals negative 10. So we have fundamentally accomplished the goal of elimination, which is to get rid of one variable. So we started off with x and y. Our new equation, 10y equals negative 10, only has one variable. So what we can do from here, algebra line straight down, is just finish solving to get y totally by itself. So in this case, y is equal to negative 1. So again, we need x and y in our answer, and an answer of y equals -1, unfortunately, is only half of what we're looking for here. We need to also get an x value. So you get to choose from the first or second original equations, take that y value, and go ahead and plug it all the way back in. So let's just do the first one. It doesn't matter. You'll get the same exact answer either way, so feel free to do it whichever way you'd like to. So if we have 4x plus 8y, instead of y, we can plug in our number. So totally just recopy that first equation. The only thing that we've done is we just took y out, and in its place we put a -1. So 4x minus 8 equals 20, because 8 times -1 is just -8. Algebra line straight down, and we can continue to solve. Divide both sides by 4. We should get a final answer of x equals 7. So our full final answer is x equals 7 and y equals -1. So let's try this one more time, except in a more challenging context. So x is on top of x's, y is on top of y's, equal signs on top of equal signs, and numbers on top of numbers, or constants on top of constants. So when we're taking a look through this here, what we have to make sure of is that something actually eliminates. So in the first example we did, 4 minus 4 is 0. So we want to check and see when we do this, when we line these up and down, does anything actually go away? So in red, 5 and 10 make 15, so that's not 0. In green, 1 and -7 make -6, which is also not 0. So neither of the x's or the y's go away. So because neither of them go away, it means that we're not done. We're not ready to eliminate here. So we have two different choices. We can either make x or y go away. And the question that you want to ask yourself is, what number would make that x or y go away? So in this case, if we're looking at green, -7, the opposite of -7 that would make it go away is just plus 7y. So what our goal is to take our first equation and make it so that it eliminates the plus 7 in the second equation. Well, as long as we keep our seesaw balanced, we could do anything we want. We just have to make sure whatever we do, it happens to both sides. So to go from just 1y to 7y's, we have to multiply everything by 7. So if we do that, 7 times 9, 7 times y, 7 times x, and this is true, it does have to go to every single term. If we don't make everything 7 times bigger, it won't be balanced on both sides. So go ahead and do this. 7 times 9 gets us 63. 7 times 5x gets us 35x. And now what we've done is we have essentially created a new question just dealing with these two equations. So that's our new focus, is just the two equations that we have. So the second equation and then the new one that we've created. And the reason why we have to do this is because if we don't, we won't actually get rid of one of our variables. So in the box that I've circled now, I'm going to ask you, go through the steps that we did on the left and solve. See what our final answer is. And I'll pause it now so you can go ahead and solve this for x and for y. All right, so following our steps here. And let's see what we got. So again, line these straight up and straight down, everything that matches, including those equal signs. Draw the algebra lines in between them, but don't forget to include the signs of whatever the numbers are. So I get 45x, 10x, and 45. 7 minus 7 is no y, 0y. And then 63 minus 18 actually gets us an answer of 45. So we've done it. We've eliminated y. We can say goodbye. And we're just left with 45x equals 45. Divide both sides by 45. And we'll get an answer of x equals 1. So again, half of the answer. Go back to the original first or second. I'll just choose the first here in this case. So 5 times x plus y equals 9. So again, just looking at our original equation here, we can plug in for x because we know what x equals now, which is just 1. So 5 times 1 is 5. Subtract 5 from both sides, and y equals 4. So our full solution is x equals 1 and y equals 4. So hopefully this review of elimination and substitution is helpful. Again, the reason why we do this is so we can solve for the exact values of where two equations intersect. And remember, they intersect at an ordered pair, an xy ordered pair, which is why every time we do this, we're going to have a value for x and also a value for y. As always, thanks for watching. If you got questions, shout them out, and you can go ahead and get started on the practice.